All right, so what we're going to do is take a look at this second section here, or the first section here, which is vertex. And let's go ahead and just save this for now, and then let's make a new scene. And it's just going to be basic URP. That way we can just focus on this, because this is going to have some advanced concepts, a little bit of math, things like that. And what we'll use this for is creating, instead of doing like an animated water movement like we would do with this scrolling UV section here, we will use this for things like flags or animating the actual vertices. And you might be like, what's a vertice again? Well, if we go in here to new shape and we create a plane, I'm going to go ahead and just drag out a plane here. Let's delete that really quick. Let's go to new shape here. With plane selected, we want to, let's see, can we edit the number of edges? I guess we can't. I thought we could. You could all right, let's just create a plane here. And let's center the pivot. And let's move this up. Now you can see here that we only have one face here. And what I want to do is subdivide this. Let's see if I think there's a subdivide tool in here somewhere. I'm going to click subdivide face, and you can see it cut into 4 quadrants. I'm going to collect that again, and I'm going to hit subdivide face, and just make sure all of this is still selected. And let's do, where is that button? Subdivide face. That's good. So you get something that looks like this pattern, where you have a lot of different faces here. And what we're going to do is we're going to displace these individual vertices here. So you can see we have all these verts. And we're going to move them up. And we'll do something like simulate a flag. And then we'll actually do something a little bit more advanced. Well, maybe we'll write a tool or something. All right, so here we have all of these vertices that we want to displace. Let me close my shader graph here. Let's save that. Let's go to our project here. And we have this thing called shaders here. And inside of here, I'm just going to create a new folder, and I'm going to call this animated UVs. And this is I'm going to dump all of these animated UV shaders in here. And we want to keep these because when you go to apply for a job, if it's as a technical artist or whatever, you want to be able to show you have some shader knowledge. Let's also make this a little bit less intensive. Let's take a look at creating a new shape here, and it's going to just be a cube. And we'll take a look at how we can move this cube, or just by moving these these has only 4 vertices, right? We have 1, 2, 3, 4 vertices on the top. So really it's about 8 vertices total. We just want to do it so that I'm going to hit center pivot here, so that this moves up and down. So we're only moving those 4 vertexes. And this is the way you could see, like you saw in the previous example, the wind was slightly moving. You could either animate it itself, or you can use this to create things like grass swaying, stuff like that. Right, so inside of here, I'm going to create another folder, and I'm going to call this wind. And this is where we're going to put all of our textures and all that stuff for this wind shader. And I'm going to go to create shader graph, URP, and I'm going to create a lit shader graph. And this is what we've been doing. This is going to be our, this will handle the displacement of our vertices. So let's go ahead and type displacement here. And we kind of know it's already a shader because of the extension. So we can either name it SG like we did before, so that somebody else doesn't know, in case they are not familiar with this icon that's a shader graph, or we'll just leave it as shader graph like that. All right, so let's click on displace shader graph here. Let's open that up. All right, so I'm going to go ahead and hit the space bar, and I'm going to type in position. And what the position node does, let's make sure we spell it right, is it lets us get the position of any object that this shader is attached to, like, so whatever we attach this material to. So we haven't created the material yet, so let's right click, just go to create, and then do material here. And you can see it says shader graph displacement SG. I'm just going to do this, and I'm going to replace SG with material. So I'll do MTRL, I'll put an underscore here. And whatever object has this material on it, so let's go back in our scene and just drag and drop this on this. What this will do is this node will grab the position of, like, so you can see your displacement material, shader graph displacement material. It's actually, it's connected to this shader graph. So because this material is attached to this object here, this will give us the current position of that object. Now default in this position node, it's set to world, and this means where's the object in the world. Well, what I want to do is I want to move the object by its personal space. So for example, if I click on this object here and I hit W, if I click on transform here, it's at this position in the world. So this is its object position. This is its current space in the world. And I want to move it up and down based on this value here. Right, so if you're familiar with your kind of like basic geometry from high school, there's these different wave functions. There's sine, cosine, and so what I want to do is if I type in time here, you can see that inside of there's different waves of time, sine and cosine. Now, sine waves, what it'll do is it gives us a value from 1 to -1. And because what this time will do is it'll move it all the way up to 1. Once it hits 1, it'll move the value all the way down. And that creates this wave. So here's like this wave going up and down and up and down. And let me see if I can find a animated video on YouTube really quick that simulates this or shows this off. I didn't find a video. I mean, there's some online, but just to make things quicker, what happens is this wave moves, and when it hits the -1 value, it passes 0, and then it goes up to 1, and it's constantly moving. This wave is constantly moving, and it's constantly going up and down. So what's going to happen is, if we go back to our shader graph, and I say, okay, I would like to add the current position of this object here, and I'm going to use this sine wave here, and I'm going to plug this into the position of the vector. Notice that this is moving, the way this is moving, and even in our preview, it's moving down and across at an angle. So if I save this and I go back into my scene, what you're seeing here is it's taking every single one of these vertices and it's moving it from 0, because 0 is the corner here. That's this corner piece here. And I'll just kind of hold this down for a second so you could see it. And it's moving them all from -1 to 1. And this up here is the highest position, which is 1, all the way down to -1 here. Now, what I'd like to do is just have it go up and down on the y-axis here. And for that, what we can do is we can use a split node to split up the x, y, and z axis here, and then we can just add sine to 1. So if I type in split here, you can see I now have 3 different values. So if I plug this in, and I say, you know what, I'm just going to add, and I know it says RGB here. R, G, and B stand for it's like our sort of X, Y, and Z axis. So let's say we now plug in just the G value here. And if we watch our preview here, it doesn't look like it's updating. Let me save this. But what's happening is it looks like it's still, oh, did I save it? Let's see. Oh, you know what? I might need to make sure that it is not adding, but it's clamping between those two values. But you can see here that it is registering just the y-axis, which is our up and down, by sine. So the way we're going to clamp that to just the y-axis is I'm just going to pull this out, and I'm going to make sure that it's just sending the value. So we have a vector 3 here, and you have an x, y, and z. And if I take this and I just plug the value here into the y-axis, which is the y of our vector 3, and I plug this into the position here, let's delete this too. That should just take the position, our current position. It splits our current position into 3 values. So we're only getting the y-axis here, and we're taking the y-axis of the current position and we're adding it to this sine here. This adds it together. And then this vector 3, because it's taking in, all this different information, we can make it focus just on the y-axis and plug that into position. So now when we go in our scene, where is our cube? Looks like, am I missing something else? Let's see. You know what? It's because we're not telling it here. We're setting it at 0, 0 in the world. We didn't set our x and our z value so that it's set to the original position, and all we're moving now is this y value here. All right, so let's save this. I'm going to hit Control S. Let's go back to our scene, and now you can see that it's moving up and down just on that y-axis. Now, as an environment artist, or specifically a technical artist, you want to give people the control over every parameter. So when I go inside of my shader here, I want to be able to have an option here where I can control the speed that goes up and down for game designers or whatever. So you probably figured out from last time, we can go ahead and just make a float value here, call it speed. Remember, a float is just a whole number. I can drag this out, and I can grab a multiply node, and I can take the sine value there, and I can multiply it by speed, and then I can connect it inside of here. And now my game designer, my programmer, my fellow artists now have this value called speed. You can see it's not moving. But if I say, you know what, I want this to go up and down pretty slowly, I can make it 0.5. If I make it a 10 here, you can see it's going pretty crazy, pretty far out there. Let's make it a 1. You can see there's that 1. Let's see what 2 does. So pretty cool. So this is just kind of the basics of creating, controlling the vector or the vertex, which is we're all plugging into here, playing with vertices of our model versus the fragment, which is the color information.